Welcome to yet another Wednesday webinar. Our topic for the day is statistics on the GRE, quartile, standard deviation, and more. So our speaker for today is Mrs. Soumya Subramaniam, who got an MS in Math from IIT Madras. She then went on to get an MS in Math from San Jose State University, and ever since she's been in the field teaching students of all backgrounds, and currently is with Galvanize as our quant expert. Moving on, I'm going to hand over to Soumya right now.
Thank you, Sana. Right. Now, before we start with this webinar, I'm sure most of you are hearing jargons like data analytics, Hadoop, big data, etc. So data analysis is a very, very important emerging field right now. And for the next, say, 20 years or 30 years, that's going to drive the world. Data analysis is one of the most important topics in any competitive exam, not only in GRE. And now we know that if you study that really well, understand it, not only from the exam point of view, also from the career point of view, it's going to be of great use to you. And particularly this particular topic is actually most dreaded from the exam point of view also. Now, what is it that this topic would include? It would include averages, mean, median, mode, that is the measures of central tendency. It would include standard deviations. It would include normal distributions, quartiles, percentiles, probability, permutations, combinations, and data interpretation. All these are covered under data analysis. Of these, the one that we're going to deal with is statistics. And in that statistics, which includes averages, mean, median, mode, quartiles, percentiles, and standard deviation, this webinar we're going to deal with only these three topics. Now, for those students who have enrolled on our platform, I know Ashish is one of our students who has been there. I'm sure he must have looked at the webinar video on averages. And for those who are not enrolled, you could Google search for our webinar videos exclusively on averages. Shortcuts to tackle averages in GRE and GMAT. That would be the topic, webinar topic, and it's already covered in on our webinars. So this webinar, I'm going to deal with quartiles, percentiles, and standard deviation. Now these are very, very less tested topics. Though they are tested, they are less tested. It is very less questions, least number of questions with respect to these three topics in GRE. But then, why I plan to take this as a topic for the webinar is, most students do not know or not familiar with these three topics. Now, these are topics which are not taught in high school in depth, or not even the basics are taught in most of the high schools. So this is one thing that you should learn anew when you're going to learn for your GRE exam. Right. Now, under that, let's start with quartiles. Quartiles, the word quartile is self-explanatory, which means given any data set, quartile is going to divide that data set into 4 equal parts. Quart means 4. So I'll have 3 quartiles, Q1, Q2, Q3, dividing it into 4 equal parts. That's the meaning of quartile. Now you must be already familiar with the term median. Median is that quantity that's going to divide a data set into 2 equal halves. Similarly, quartiles, there are 3 quartiles, first quartile, second quartile, and third quartile, which are going to divide a data set into 4 equal parts. Let's look at an example to try to understand this concept better. Now, for example, suppose you have a data set, say 1, 3, 4, let me have a 5 here, a 6, 7, 8, and a 8. Number of observations 3, 4, 5, 6, 7, 8, 9, 10. There are 10 observations here. 10 is an even number. When you have an even number of observations, and you know the method to find the median. Now, median quartiles, they're very similar in the way you calculate them. Right, median dividing the data set in 2 equal halves. So what do you do when you start calculating the median? You're going to sort the data set in ascending order. So similarly, the same thing that you do for quartiles also, you first check if the data set is sorted or sort it in ascending order. So look at this data set. This data set is already sorted. To find out the quartile, first you need to find out the median of this data set. There are 10 elements here in this data set. There are 10 observations here. 10 is an even number. To find the median of an even number of observations, you need to take the average of the fifth and the sixth observation. That will be 10 by 2 and 10 by 2 plus 1th observation. That's the formula, right? So you need to take the average of 3, 4, 5, fifth and the sixth observations. If you take the average, that will be 1, 3, 3, 4. You take the average of fifth and the sixth observation, that will be 5 plus 6 by 2, which is 11 by 2 or 5.5. I want to insert this 5.5 here. I've got this median as 5.5. As you can see, this 5.5 has divided this data set into 2 equal halves. There are 5 elements to the left and the 5 elements to the right. Having got the median actually is nothing but the second quartile. As you can see, quartiles divide into 4 equal parts, which means the second quartile has divided this data set into 2 equal parts. 50% of the observations lie below Q2, 50% lie above Q2. If you look at Q1 and Q3, you can see that 25% of the data set is here, 25% is here, 25% is here, and 25% is here. Can you see that? It is divided into 4 25%. That makes it 100%. Right. So to find out the quartile, Q2 is nothing but the median. That's your first step. Q2 you have got. Now the next step is to find Q1. You will take the lowest value and Q2 and find the median of this set of observations here. 1, 3, 3, 4, 5, 5.5. Out of these, there are 3, 4, 5, 6 elements in this data set. Again, you need to find the mean of 3 and 4. That will be 7 by 2, which is 3.6. So my next step will be to insert this 3.6 here, which is Q1. I've got the first quartile, which is nothing but the median of the first half of this data set, right? 50%, the first 50% of the data set, you take the median, actual median that you have got, and the first value, take the first half and find the median of the first half. So you've got it as 3.6 here. So that will be your Q1. Now I've got this Q2 as 5.5. Now I need to find out Q3. Again, the same procedure. I take Q2 and the last value, take this chunk here till this. So if you take this chunk here, you get it as, the number of observations is 6 again, 6 plus 7 by 2, 13 by 2, 6.6. That's going to divide this into 2 equal parts, and Q2 is dividing the entire data set into 2 equal parts. Q1 is dividing the first half into 2 equal parts. Can you see that? 3.6 is Q1, Q2 is 5.5, and your Q3 is 6.6. I have 3 quartiles which has divided this data set into 4 equal parts. Right. Now, this is not what is asked in GRE. As you know, GRE is a skill-based exam, right? Skill-based exams don't test on direct calculations. They don't ask you to calculate what is the quartile, find the median. So it's all more of application-based. So let's look at a typical GRE type problem with respect to quartiles. Select exactly one answer choice. This is a multiple choice question. The company at which Mark is employed has 80 employees, each of whom has a different salary. Mark's salary of $43,700 is the second highest salary in the first quartile of the 80 salaries. If the company were to hire 8 new employees at salaries that are less than the lowest of the 80 salaries, what would Mark's salary be with respect to the quartiles of the 88 salary? It is very, very confusing if you read this as a whole chunk, right? Now, first step is to understand the meaning of quartile and then understand this question. So to understand a word problem, again, those who are enrolled, you must be familiar with our webinar on understand how to tackle word problem and this mnemonics spice. When you have a word problem, it is advisable to follow this mnemonic spice. That is, break it into parts, collect the information, connect them in the form of a table or a diagram, frame an equation, and then solve them. That's the best way to approach word problems. So breaking it into parts, that's very, very important. If you read it as a whole, you will not be able to understand what the hell this particular problem means. As I told you, there'll be at the most 1 or 2 questions with respect to quartiles in GRE. But whatever question that you encounter in GRE will be of this type. It will be a word problem where you need to apply the concept of quartiles that you learned. So which means your concept clarity in quartiles is very, very important. Note that a quartile is going to divide a data set into 4 equal parts, which means there are 3 quartiles given in the data set. First quartile Q1, Q2, Q3. 3 quartiles, and there will be 4 regions. 4 equal regions will be there. The company at which Mark is employed has 80 employees. Now, since we are dealing with quartiles here, there are 80 employees. We're going to divide it into 4 equal parts, which means I have 20 employees in each category. Let me have this first quartile region. Let me call this as first quartile region or Q1 region. Q1 region is those numbers below Q1. So I'll have 3, etc. There'll be 20 salaries in the first quartile region. As you can see, you're looking at the salaries here. That's the chunk that's the word that you're looking at. That's a keyword. That's a watchword here. Looking at the salaries. Salaries of the first 20 employees in the first quartile. Then the second quartile will have the salaries of the next 20 employees starting from 21 till 40. Then the third quartile, that is Q3 region. I'm not going to call it as Q3. Q3 is a number. I'm going to call it as a region here. 41 to 61. 60, I'm sorry. Then Q4 region or the fourth quartile will have 61 to 80. So I've divided this data set into 4 equal parts. Now, since we are dealing with quartile without loss of generality, we assume that the data is sorted and we have divided it into 4 equal parts. The question says, the company at which Mark is employed has 80 employees. So all the 80 employees' salaries are covered here. Each of whom has a different salary, of course, yes. So which means there is no repetition here. Mark's salary of $43,700 is the second highest salary in the first quartile of the 80 salaries. Which is the first quartile in the 80 salaries? That is this first particular column. Second statement says Mark's salary is the second highest salary in the first quartile. Second highest. As you can see, the data is sorted. So we are going from the lowest to the highest salary. Which means in the first quartile, 20 is the index 20 or the 20th salary is the highest salary. Note that I am not looking at the salary here. I am just looking at the index here. Right. So the 20th salary is the highest salary. The second highest salary will be the 19th salary. So according to the second statement, Mark's salary is the second highest salary in the first quartile. So the Mark's salary position is here. Can you see that? It is the second highest salary in the first quartile. Done. Now, look at the third statement. If the company were to hire 8 new employees at salaries that are less than the lowest of the 80 salaries. Very interesting. So the company is going to hire 8 new employees, and all these employees' salaries are less than the lowest of the 80 salaries. Of these 80 salaries, which is the lowest? As I told you, the data is sorted in the ascending order from small to big. So the lowest salary here is the first salary. So the new employee salaries are lesser than the first salary, right? So I'm going to reframe this quartile here. So I'll have the first quartile will be, I'll have 1, 2, 3, 4. As you can see, since 8 new employees are added, there'll be 88 employees. So each quartile, if you're going to divide 88 by 4, you will get 22, which means each quartile, instead of 20, you will have 22 salaries in each quartile. Second quartile will have 22 salaries starting from 23, 24, 25, 26, 27 till 44. And then you will have the third quartile starting with the 45 and it will go on till 66. And the fourth quartile starting with the 67 will go on till 88. I have accommodated the 8 new employees here. 7, 8, 9. Now the 8 new employees are here. Their salaries are lesser than the original employees here. So they belong to the first quartile. Right? So the 8 new salaries are here. Now if you look at the first salary, that is the first original salary, the lowest original salary in the new list, the new quartile list, it has come to the 9th position. That is, it has been shifted because there are 8 new employee salary which has been added. So it is in the 9th position, which means every index has been shifted by 8 units. One has come to 9, second salary has gone to the 10th position, third salary has gone to the 11th position, and so on. So where do you think the 19th salary would have gone to? You're worried about the mark salary here. 19th salary would have gone to 19 plus 8, which is the 27th position. So, can you see that it has fortunately gone to the second quartile, right? So, mark salary, the question is what would mark salary be with respect to the quartiles of the 8 salaries? There are 4 options here. The 4th highest salary in the first quartile, that's not it, because the 4th highest salary in the first quartile is among the 8 employees. The highest salary in the first quartile is 22. No, the mark salary is in the 27th position. So 27th position belongs to the second quartile, and it is in the 1, 2, 3, 4, 5th position in the second quartile. The 5th lowest salary in the second quartile. The answer is option E. This is a very typical GRE problem with respect to quartiles. Right. Now, a very similar type. Now, medians, quartiles, and percentiles are very, very similar to each other in the approach. Right? Median divides it into 2 equal halves. Quartiles divides it into 4 equal parts. The next very important topic, standard deviation and normal distribution. So what do you mean by standard deviation? You need to understand this concept very clearly. Standard deviation is actually a measure of dispersion or scatter. How well a data in a data set is moving away from the median. That is what is called as standard deviation. Moving away from the mean is called as standard deviation. Mean, as you know, is a measure of central tendency, right? What do you mean by central tendency? It assumes that it is one representation of the entire data set. If the data is dispersed more away from the standard deviation will be more. If the data is dispersed more away from the mean, suppose I have a mean here and all my data is here, then I would say that the standard deviation of this particular data set is very high. Suppose the mean is 5, I'll have quantity say minus 1, minus 2, minus 3, and I have quantity say 10, 25, 49, 72, then the standard deviation of this data set is very high. The mean is 5 and this is dispersed high, this is also far away from the mean, so this standard deviation is very high. So standard deviation is just a measure as to how much the data set has been deviated from the mean. So what are the rules that you should know? Nobody is going to ask you to calculate standard deviation. There's a very, not a nice formula to calculate standard deviation. It says x minus x bar the whole square by n, square root of this. It's very, very hard to find out unless you are given a calculator and you know that you have an online calculator in GRE. Still, GRE is a skill-based exam and they don't want you to do tedious calculations. So 99% of the questions in standard deviation would be on just application, very simple questions, provided you know the concept properly. Now, there are 2 facts that you should understand when you deal with standard deviation problems. Now, when you deal with mean, suppose you have data like this, A1, A2, A3, etc. Suppose I have 5 elements in a data set, A4, A5. Now, I am assuming that the mean of this data set, I call it as mu. The standard deviation, I call it as sigma. These are standard notations for mean and standard deviation. A1, A2, A3, A4, A5 has got mean mu and standard deviation sigma. Suppose I'm going to add a constant, say 2, to every element of this data set. So what happens to the mean? Those of you who have seen my webinar video on averages, you would know that the mean also shifts by this constant, shifts 2 units to the right by this constant, right? Mu becomes mu plus 2 now. The new mean is mu plus 2. But then when you add it, the standard deviation remains the same. The new standard deviation will be same as the old standard deviation. But then when you multiply it by a constant, suppose you have another data set where every element of the original data set is multiplied by 2, or I made it twice the original elements, then the new mean will be 2 mu, and the new standard deviation will also be multiplied twice. But when you add, it doesn't have any effect. The standard deviation remains unchanged. Now this is a very important rule that you should know before you proceed with standard deviation. So what is a typical GRE type question? If you look at the question, you know that it's a very, very simple question. As I told you, standard deviation measures how deviated is it from the mean. Below are two sets of numbers. Which set would you say has greater standard deviation? I have a set 1, 3, 5, 7, 9. 2, 4, 6, 8 is another set. So first step is you will have simple numbers like this. So which means it's easier for you to find out mean, which is given by x bar or mu. For set 1, the mean would be the sum of observations by number of observations. 1 plus 3 is 4 plus 5 is 9 plus 7 is 16 plus 9 is 25. By 5, it has to be the middle value 5. Later, you know this is also a normal distribution, so the middle value has to be the mean median. Right? So the second one, set 2, the mean will be x bar is equal to mu will be 4 plus 6 by 2, that is 4 plus 6 is 10 by 2, which is 5. So in both the cases, the mean is the same. So I'm going to insert this 5 here. Now, as I told you, standard deviation measures how much the data set is deviated from 5. So mean is 5 in both the cases. As you can see, let's look at the first two values. There is a 1 unit difference. 1 unit below is 4, 1 unit above is 6. But then here in the first set, there is a 2 units difference between 3 and 5 and 7 and 5. Right? So which means, suppose I'm going to plot this 5 here. My 3 here, the first data set, 3 is here, 7 is here. And then furthermore, I have 1 and then 9. But then if you look at the second data set, 5 is here, the previous element is here, the next element is here. And the previous element is here, the next element is here. So which means there is some kind of closeness of this elements of this data with this mean. The data set is more closer to the mean in the second set than in the first set, which means the first set is dispersed more. There is more space between every element in the data set. So set 1 has more standard deviation. So all you need to do here is just calculate mean. Standard deviation of set 1 will be greater than standard deviation of set 2 because the data elements, as you can see, are dispersed more in the first set. Right? It's only by observations. I have not calculated the standard deviation here using that tedious formula. Let's look at one more example where you just have the graph, you just have to find out the standard deviation. Now, normal distribution. There's one more term that you should understand. What is a normal distribution? It's a very, very interesting, nice bell-shaped curve. It's also called as a Gaussian curve. Normal curve is also called as a Gaussian curve, a bell-shaped distribution. How do you arrive at this bell-shaped distribution? You would have seen this, that this normal distribution is symmetric about the mean, blah, blah, blah. So many things have been told about this normal distribution when you Google search about this normal distribution. What does this mean? Now, normal distribution is actually an approximation to the histogram that you draw. Now, for example, suppose you're going to look at the height of students in a particular class. I'm going to find out the mean of students in a particular class. Now, when you say the data set is normally distributed, suppose I'm going to plot the histogram. Histogram will have height on the y-axis versus the students on the x-axis. There'll be a student who has got some height, say 157 centimeters. I can have students here, 157, and here I could have a 156, 155. There could be 2 students in 154 range. I could have a repetition also. There could be students in 153, 152. And again, on the right hand side, that is number of students who are more than 157 will also more or less follow the same pattern. When you draw the histogram of the heights of students in a particular class, if the histogram looks like this, Suppose I'm going to join the peaks of these histograms. I'm going to join it like this. Can you see that when you trace it, you get a nice bell-shaped curve? How did you get this bell-shaped curve? You have got a data where the mean height, let me call that mean height as 157, and the number of students who have got heights less than this 157 is almost equal to the number of students who have got heights greater than this 157. 157 is the average height of the students, but number of students who have got the height less than 157, that is this part, is almost equal to this part. So, which means the data is symmetric about the mean. This is the axis of symmetry. 50% of the data set lies here. 50% of the data set lies on the right side of this mean. This is the center point. This is the mean of this data set, right? This is called as a normal distribution. Whatever is there on the y-axis when you draw the histogram, I've transferred it to the x-axis here. This mu stands for the mean height. 50% of the students, that is this, let me call this as a population. I could say that the number of students who have got a height less than this mean height is 50%. Number of students who have got a height greater than this height, 50% is, greater than this mu is also 50%. That is what is normal distribution is all about. Quantity A, standard deviation of A, quantity B, standard deviation of B. So here it says it's a normal, there are two normal distributions with the same center, which means the mean is here. This is the axis of symmetry, and this is one normal distribution, another normal distribution. As you can see, just from it, the peak to 1, and that is one that has got a greater base. As you can see, this data is more scattered from the mean. Mean is taken to be 0 without loss of generality, but not a practical application though, but still only for a problem's sake, this problem has been given. And as you can see, there is a minus 15, 15. There is a discrepancy or a range of 15 units here, but whereas here, there's a range of 5 units, right? So the standard deviation of B is more, and so B is greater than A, just by looking at this curve that's given here. Let's look at one more question. W is a random variable that's normally distributed, which means W could be, as I told you in this example, could be the height of students with a mean of 5 and standard deviation of 2. Now, normally, when you look at normal distributions, there is a standard lookup table. That is what is just lookup percentages, and all the questions under normal distribution are based on these percentages only. The percentages states that if this is the mean, let me call this as mu. Instead of 0, I'm going to call it as mu, and this would be mu minus sigma. This would be mu plus sigma. This would be mu minus 2 sigma, and this would be mu plus 2 sigma. I still have, I'm going to have it as 1% here, 1% here, and this would be mu, this point will be mu minus 3 sigma, mu plus 3 sigma. All these sound a little weird to you, right? Let me explain to you what it means. Now, when I say mu plus sigma, which means there is a little discrepancy from the standard deviation, which means the number of people in this range are one standard deviation above the mean. The number of people in this range have a height which is minus 1 standard deviation above the 1 standard deviation less than the mean. That's what it means. So 34% of the population have got height less than that of mean, and 34% of the population have got height greater than that of mean, but less in this area, mu minus sigma to mu plus sigma. So putting it as a probability distribution, you know that P of W is a random variable, mu minus sigma less than mu plus sigma. It's actually between this and this, it's 34 plus 34, 68% of the population. The probability that you can find a person with a height lying in this particular value between mu minus sigma and between mu plus sigma is 68% or 0.68. The chances of a person having a height lying in this range is 60.68, and then P of mu minus 2 sigma less than W less than mu plus 2 sigma will be equal to, it's 14 plus 14, 14 plus 34 plus 34 plus 14, that will be 68 plus a 28, that would give me 96%. Now 96%, or some reference materials call it as 95% also, not wrong. you could have a 0.01% difference. P of mu minus 3 sigma, sorry, less than W less than mu plus 3 sigma will be equal to, between this and this, that's actually given by 0.99 or 99%. And as you know, since it's symmetrical, so this particular side has to be 50% and this side, the population density, has to be 50% here. Going back to the question, P of W greater than 5. Now, when you try to solve these problems, before you try to solve these problems, you need to find out what is mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. Mu is given to be 5 here. So let's first try to calculate all these values and keep it. Mu is 5 here. Sigma is given to be 2. So mu plus sigma will be 7 and your mu minus sigma will be 3 and mu plus 2 sigma will be 5 plus 4, which is 9. Mu minus 2 sigma will be 5 minus 4, which is 1. Mu plus 3 sigma will be 3 times 2 is 6, which is 11. Mu minus 3 sigma will be 5 minus 6, which is minus 1. Now, once you calculate this, finding out this value is very easy. P of W greater than 5. Now, 5 is nothing but, as you can see from this, it is mu minus, mu. 5 is actually mu. P of W greater than 5 transforms to P of W greater than mu. As you can see, 50% of the data set lies above mean. So this answer is actually without any calculation. If you're thorough with this percentages, then it's actually 0.50 or 50%. P of 3 less than W less than 7. 3 is mu minus sigma, 7 is mu plus sigma. And take my word, this is how the questions are worded with respect to normal distribution in GRE. Mu minus sigma less than W less than mu plus sigma. So this is actually 34 plus 34, 68%. So this value is 0.68, which is greater. Quantity B is greater because that's equal to 0.68. That's all his answer. Going to the next question. W is a random variable that's normally distributed with a mean of 5 and standard deviation of 2. Which of the following numbers is the best estimate of P of W less than minus 1? As you had seen in the previous question, it's the same question, but the quantities alone, the value alone are different. The mean is given to be 5 and standard deviation is 2. With this, minus 1 is mu minus 3 sigma. If you look at this, the question is P of W less than minus 1, which is P of W less than mu minus 3 sigma. As I told you here, I have to put a block here. This is 1%. This is your mu minus 3 sigma. As I told you, P of mu minus 3 sigma less than W less than mu plus 3 sigma, it's actually 99%, which means the values here to the left of mu minus 3 sigma and to the right of mu plus 3 sigma. So this is your mu plus 3 sigma. This particular shaded region contributes to only 1%. 1% is nothing but 0.01. Since the data is symmetrical, 0.01 by 2, 0.005 of the population lies here and 0.005 of the population lies here, right? So mu of W less than mu minus 3 sigma is actually 0.005. That's your option E. Now, as I told you, data analytics is a very, very hot topic of late, and you need to understand these concepts. Standard deviation, normal distribution, very, very important, not only from the exam point of view, though there's just 1 or 2 questions. Each question, you should have concept clarity to answer those questions. So it's not only important from the exam point of view, also from your career point of view. Right. Over to Sana.
Wonderful. Okay. So that's all for now. Until next Wednesday, this is Sana signing off. Thank you.